Real-world data never arrives clean. You'll get spreadsheets with blank cells, numbers stored as text, and columns that look correct until you try to do math with them. This is the reality of data work. Whether you're pulling a report from your CRM, exporting campaign metrics, or consolidating quarterly numbers. In this video, we'll learn how to detect and handle missing values, fix incorrect data types, and turn a raw data frame into a polished table. These are the skills that separate someone who can follow a tutorial from someone who can actually work with their own data instead of resorting to cleaning it by hand in a spreadsheet. Let's get started. By the end of this video, you'll be the kind of person who can open up a messy CSV and know exactly what to fix before running a single analysis. This video builds on the earlier videos in the series, covering Python installation, virtual environments, JupyterLab, pandas, polars, and reshaping data. If you need to catch up on any of those, links to the earlier videos are in the description. Let's navigate to our project folder and activate our environment. With our environment active, let's launch JupyterLab. In JupyterLab, create a new notebook by clicking the Python tile on the launcher. Then right-click on the tab and rename it to something like Data Cleaning. Before we write any code, let's understand what missing data looks like in Python. Pandas and polars handles it differently. In pandas, missing values are represented by NaN, not a number. And this comes from the NumPy library. The important thing to know about NaN is that any math involving NaN produces NaN. It's contagious. And after importing libraries for this project, we can run a simple example. Here, NaN plus 5 is nothing. NaN propagates through every calculation it touches. Polars uses null instead of NaN. The behavior is similar, null values propagate, but polars is more explicit about distinguishing between null, meaning this value is missing, and NaN, meaning this is a number that resulted from an undefined operation. For most beginners, the practical difference is small, but it's worth knowing the terminology. Let's build a data frame that looks something like you might get from a colleague. Yearly sales data with a problem lurking in the last row. Let's see what this looks like. At first glance, this looks like a table with missing values in the 2025 row. But here's the catch. Those NA entries are strings, not actual missing values. Someone typed the letters NA into a spreadsheet, and pandas imported them as text. Let's check with the isna method and some of the results. 0 missing values detected in every column. Pandas doesn't recognize the string NA as missing, it's just text. This is exactly the kind of silent problem we've talked about in previous videos. To fix this, we replace the string NA with an actual NaN value, and we can use the replace method. Now let's check again. Now pandas correctly identifies one missing value in the units and one in the total revenue. Once you've found missing values, you have a few common options. Drop the rows, fill with a specific value, or fill with a computed value. To drop any row that has at least one missing value, we can use the drop-NA method. Here, we went from 6 rows to 5. In this case, that's reasonable. We're dropping an incomplete year. But with larger data sets, drop-NA can be aggressive and remove more data than you might like. Instead, you might fill the missing values. For example, filling them with zeros. Or you can fill with the column's mean. Now, the missing unit value is replaced with the average of the non-missing values. This can be useful when you need a reasonable placeholder. For example, if the 2025 data hasn't been reported yet, but you need to run a preliminary analysis using the historical average. Which approach you choose depends on your data and your analysis. There's no universal right answer. Let's see the same operation in polars. We'll create the same sales data frame, but in polars, and we use none to indicate the missing values. So let's take a look. Polars displays the missing values as null, and to count them, we can use the null count method. Cleaning is straightforward. To drop rows with missing values, we can simply use the drop nulls method. And we can fill missing values with a polars expression. Back in our Intro to Pandas video, we saw what happens when a number is stored as a string. Multiplying it gives you repeated text instead of a calculated result. Let's see how this shows up in a real workflow. Remember our original sales data frame 2, the one with the NA as strings. Let's check its data types. Units and total revenue are both objects. Remember, this is Pandas' way of saying these columns contain mixed types. Let's use the polars version of our sales data to demonstrate the cast method. Let's check the data types. Now let's say we want to convert the year column from an integer to a string for categorical use. The cast method in polars converts a column from one data type to another. This becomes especially important when you're preparing data for visualization, where chart libraries may require specific types like categorical or string. Finally, let's take our sales data and make it look polished. The Great Tables library can transform a plain data frame into a publication quality table. Here, from Great Tables, we're importing GT. You may need to load the Great Tables library with pip. Let's build on our cleaned sales data. We'll add an ASP column, average selling price, and format everything into a presentable table. Here, I'm working in polars. I'm going to drop the nulls, and then I'll use with columns to create the ASP column. And now let's pass this to Great Tables. Here, I'm just using the tab header method and adding a title and subtitle. From raw data with missing values to a clean caption table, all within a single notebook. This is the kind of output you could share in a report or a presentation. That wraps up this video. Let's look at where we've been across the series so far. In the first set of videos, we built our development environment, installing Python using winget, created a project folder with a virtual environment and pip, and launching Jupyter Lab for interactive coding. Then, in the second set, we built on that foundation. We introduced pandas and data frames, showed how polars offers a more readable alternative, covered reshaping data, and feature engineering. And in this video, tackled the messy reality of missing values, broken data types, and polished output. You now have a working Python environment and the fundamental skills to load, manipulate, clean, and present data. Where you go from here is up to you. Visualization with Plotline, machine learning with scikit-learn, or deeper into the pandas and polars ecosystem. If you're finding this series helpful, subscribe to the channel for more content on how business and marketing professionals can use Python to enhance and automate complex analysis in their everyday work. And if you want to go deeper in any of these topics, check out the companion book, Getting Started with Python on Windows 11. The link is in the description. Thanks for following along, and I'll see you in the next video.